Hello, welcome back to a new video in the Java for Beginners series. In this one, we're going to look at looping, the ability for your Java program to execute the same code over and over and over. We're going to look at the for loops, the while loops, the do while loops. This sounds like fun? Continue watching. So looping is a mechanism that your program utilizes to execute a line of code in this case, or a number of lines of code potentially, or a block of code for a number of times. To show you an example just right out of the gate, I'm going to execute on the code that I have here, and then we're going to explain it. But just to see what it does, I'm printing 1, 2, 3, 4, 5. Okay, so what's happening here? I have one print statement, but I'm getting 5 numbers printed. So apparently there is some sort of a looping mechanism that is going on that is allowing me to execute this multiple times. Of integer I equals 1. Well, I noticed that the first number I printed is 1. I have I less than or equals 5. Well, the last number I printed is 5. And then I have I plus plus, which will modify the value of I by saying I equals I plus 1. So it's incrementing the value of I by 1. So I see an increment here from 1 to 2 to 3 to 4 to 5. So we're beginning to see what's going on here. Let's change this to 15. Hit run. Well, I see that the numbers from 1 all the way through to 15 are being printed. Change it to 150,000. I see all the numbers from, well, you're going to have to scroll for a long time, but I see all the numbers from 1 to 150,000 being printed. So you see the power, how powerful this can be. Is like you can get your program to execute a line of code for any number of times that you like. Now, let's talk a little bit more about what is going on and break it down piece by piece. For every for loop, there is a particular structure that you have to follow. You start with the for keyword, and you have a pair of parentheses. And optionally, and we're going to talk about that in a bit, you have a pair of curly braces. And so inside the parentheses, you have 2 semicolons. And so I'm going to assign just names for each area in the for loop. So this being area 1, this being area 2, this being area 3, and this being area 4. So to map it on the for loop example that we have here, this is area 1, this is area 2, area 3, and area 4. Cool. Now I'm going to show you, just going to make it a little smaller. I'm going to show you how the for loop works. And basically what we're going to do is we're going to follow step by step how the execution will take place. And the first thing that we're going to execute is area 1. So we start by executing area 1, which has a very familiar syntax that we've seen many times, which is int I equals 1. So that'll define a variable in memory, and the value of it is going to be initialized to 1. Now, once we've executed the area 1, we're done with it. We can just stop looking at it because that's the last time. The first and the last time we're going to reference it. For the rest of this, we're going to look at area 2, 3, and 4. So we've executed area 1. We're done with it. Now we're going to jump to area 2. And in area 2, we see that there is a condition, I less than or equals 5. So we're going to evaluate the condition in area 2. And of course, each condition either evaluates to true or false. And if it evaluates to true, then we're going to continue by executing what's in area 4, which is the block of code that is contained within the for loop. The piece of code that we're meant to be executing potentially 0 times, 1 time, or multiple times. And if it is false, then we just don't do anything. We don't execute block 4, and we break out of the for loop and we move on to the next thing. So in our case here, it is true because the value of I is 1, and 1 is less than or equals 5. So it is true. So we're going to execute area 4. Area 4 contains the print statement, system.out.print line I. So we're printing the first value of I, which is 1. So we're going to print 1 here, executing area 4. So that's like a play button that we've executed it. And then what we're going to do is we're going to go to area 3. Now, area 3 has a condition update. So that's usually where you update your iteration condition, which is I in this case. So area 3 has a syntax that we've seen before, which is I++, which translates into I equals I plus 1. So what we're doing here is we're saying I equals I plus 1. So 1 plus 1 equals 2. So the value of I will be incremented by 1 and the new value will be 2. And so once we've executed area 3, then we're going to go to area 2, which is the condition here. And then we're going to evaluate the condition and see if it's true or false. So the condition that we have here is I less than or equals 5? The value of I currently is 2, which is less than 5. So the condition is true. So we're going to go ahead and execute area 4. And now you start seeing a pattern here. Let me explain. So after the first initial step, we executed area 2, then area 4, then area 3. That's one iteration. Then we're back at area 2, area 4. So we're going to print out the value of I, which is the new value 2, right? So we're going to print this value here. And then after, we're going to go to, as the pattern will show us, A3, where in A3, we update the value of I. So the value of I will be incremented to 3. And then we go from that, so going back to green, just to show that our pattern is now repeating itself, we're going to go to perform again area 2, which is the condition. Is I, which now happens to be 3, less than or equals 5, either true or false, which in our case is true. And then we go to area 4 and we execute the code. So we execute for value 3 and we print it. And then we're going to go again to area 3 and we're going to increase the value from 3 to 4. And then we're going to go to area 2 and then perform is 4 less than or equals 5, true or false? Well, it is true. So we're going to go to area 4 and we're going to print the new value of I, which is 4. And then we're going to, again, go to A3. So I will be 5. And then we're going to say in area 2, is 5 less than or equals 5? And the answer is true. So we're going to go to area 4, print the value of I, and then we're going to go to area 3. So the value of I becomes 6, which is when we go to area 2, which is the condition, is 6 less than or equals 5, either true or false. And here it's false, so we exit out of the loop and we don't go to area 4 anymore. And so the last value printed is 5, but the last value of I is 6. So going back in the editor, I'm going to hit the debug button. But before I do that, I'm going to set 2 breakpoints, one at the beginning of the loop and one inside the loop. Okay, so I'll hit debug right here. And so this will allow us to step line by line through the code and figure out what the values are as we are executing the code line by line. And the value that we're particularly interested in is the value of I, which isn't really declared yet here because we haven't really begun executing the loop, which is like the first thing that we're going to execute, which is area 1 here. And then we're going to evaluate area 2 and see if that's true or false. So if I hit F8 on my keyboard, I get a variable primitive type integer being created and initialized to 1. And the condition here is true. So the program pointer is now inside the loop, which is area 4. And if I hit F8 again, I see that the value of I was printed because of the print statement. And then I'm back at the top of the loop. But notice the value of I is still 1. So I don't need to hit F8 again. And I see that the value of I was changed to 2. And of course, the condition was evaluated And so I'm back inside the loop. F8 again, I get 2 printed, value is still 2, then increase to 3, and then I hit F8 again, 3 is printed, 4, 5, and then the value is still 5. And once I hit F8 again, the value of I, well, was increased to 6, and then the evaluation of this was false. But then notice what happened. The value of I is gone. And that brings us to an interesting point. And now that's the end of it. So I can hit F9 and terminate the program. Now, this variable I is only available inside the scope of the loop. So outside the context of the loop, the value of I is no longer needed. So it is just discarded. Now, as it turns out, you don't have to have stuff in area 1, area 2, and area 3. You can move those stuff outside of those areas and still accomplish the same result. So you can literally leave them free, but you have to do something about moving those, the things that you have in there, moving them elsewhere to achieve the same effect. Let me show you how. I can take this into I equals 1, cut it, put it at the top here, and put a semicolon after, and it'll still work, you see? However, when I do debug the code, just gonna redo everything. So F8 all. So when you hit 5 and you print that and you go in here, you see that I was incremented to 6, but if I continue, the value of I remains. The reason why it remains because the declaration of I is not within the 4 contexts. So the value of I will outlive the execution of the 4. So actually, if I go here and execute print I, what I will get is 6 right after, you see? Now, if I move this back inside here, as it was before, I'm getting an error here, cannot resolve symbol I. So symbol I being a variable that should have been declared outside to outlive the for loop. So that's area A, really just optionally, like you don't have to fill it. It's just optionally filled. And it makes the code looks neater. And also, if you really have no use for I outside of the context of looping, then you really shouldn't make I outlive the for loop. It should die with it. Also, this happens to be something that maybe you can add to the end of the iteration. I mean, you know, as if you remember, we execute area 1, then area 2. Then if area 2 is true, then we execute area 4. Then we do area 3, then area 2, then 4, then 3, then 2, then 4, etc. So if you're doing area 4, then area 3, so you might as well just have the increment of your counter at the end of area 4. And then this can be empty. And I'll prove it. If you hit run, you get the same result. Now 6 is being printed as part of the statement at the end, but you see it's the same result. Now it turns out we can also remove the middle part, which is area 2. But to remove it, we need to take into account when it gets evaluated. So when I enter the loop for the first time, I'm going to evaluate this one, which would be here, and then I'm going to evaluate the loop condition, which is area 2. So the loop condition is what keeps the for loop in check, is what tells the for loop when to terminate, when to enter and when to terminate. So if we actually get rid of that condition for a little bit and hit run, we're going to have an infinite loop, basically, as you see here. It's just going to print numbers forever. We don't want that. That's not good. So what we can do is we could say if, and put the condition in there, and then put the logic of the loop inside the condition. But that is not enough, because what that'll do is it will only execute this logic when the loop holds, when the condition of the loop holds true. But nonetheless, when it doesn't hold true, you see it didn't give me the program terminated. I still see this stop main button. So just a refresher how it looked like before. When the condition was in the appropriate place, and I hit run, I got process finished with exit code 0, and this button for stop is no longer clickable. I don't get that the process is finished and I can stop the program, which means I'm also stuck in an infinite loop. So what do I have to do? What I have to do is have an else and say just break, which will, if you hit the break statement anywhere within your loop, it will terminate the loop and just go outside of the bounds of the loop. So if you run this, you will get the outcome that you have expected, and you get process finished with exit code 0. Very similar to for loops is the while loops. Let's have a look and see how they compare. Now, while looks similar to for, but instead of having those area 1, 2, 3 and the dividers, it has just one area, which is in the for loop, area 2. So this original condition that we had in the for loop, you keep that here. Now I'm going to get rid of that if, and then the equivalent of our for loop, that, let me do it again here, just to refresh your memory, and I equals, let's use another name, so j equals 1, j is less than or equals 5, j plus plus, and then we were doing j. Well, this is with the exception of I, this very same loop that we have here, right? And so what we've done is we've moved area A outside and area 3 within the body of the loop, and then that's our area 2. So I'm going to comment this out and run this, and I get the same result. The way you do it is you define your looping variable, which here happens to be I, and then you define your condition that you want to keep looping while it holds true. And the way the way it works is you're going to first execute that, and if it's true, you execute what's in here. If it's false, you don't execute anything. So if I start with a value of I that is equal to 7, and I try to see if anything will get executed, well, nothing got executed. Why? Because it tried to evaluate, is 7 less than or equals 5, and the value was false, so this was never executed. If I go with a value of, say, 5, it'll be executed just once, which is the 5, and then the value will be 6, and then 6 will not hold true. Now, there is a form of loop called do while, which basically looks like this. I can have I less than or equals 5, and in here I can have my print statement. So I'm going to get rid of this for now, and a semicolon at the end. Now I'm going to change this to 7. Remember now 7 didn't work in our previous example. Let me just see what it's complaining about. Oh yeah, it's not being updated inside the loop. That's a good point. So I was not executing before when we had the while example. It was not being executed because the condition was false. So it never executed the print statement. However, if I try to run this, I'm going to get 7 executed and that's it. So what does do while do? Do while will have a different flow in the sense that it will execute the block area 4 first at least once, and then it will evaluate the condition. And if the condition holds true, then it's going to execute that block again, and then evaluate the condition. And if it's true, execute the block again and again and again, and so on. So if I change that value to 1, I'm going to get pretty much the same result, but I know that at least the first iteration, did not have the condition checked, and I can prove that. So I can change that value to 7, right? And then if I hit run, I get only 7 executed. I wanted to talk to you about one more concept. So we've seen the break. I'm just going to comment this out actually just for a second and run this again. So this prints the numbers from 1 to 5. So say that we want to stop for some reason at 3. So I could say if I equal 3, then we've seen the break statement. It will just break out of the loop and the execution. So obviously, because at number 3, we broke out before we got the chance to print. So we got 1 and 2. Turns out there is another keyword that you can use, and it's called continue. I can't spell. And basically what happens when you use continue, or the difference between it and break, is that continue will basically skip the iteration that you're in and move on to the next iteration. So we see 1, 2, 4, 5. So 3 was skipped. The reason why it was skipped is because we had this if statement here. So let me give you an example where this is useful. Say I mod 2 equal 1. Then what I'm basically saying here is execute continue if number is odd. So if number is odd, I'm just going to continue. And if not, well, I'm going to get to the print statement. So this effectively will print all the numbers, and I've updated this to 20, from 1 to 20. So it'll be 2, 4, 6, 8, 10, etc. Let's hit run and see that being executed. As you can see, we got all the even numbers printed. And if you change that to 0, well, then we're going to get all the odd numbers printed and all the even numbers skipped. Let's consider more examples to do with looping. So I've got a for loop here. I've got an I equals 2, I less than or equals 10. So nothing really special here, except for now, what our update for the counter, it's not I++, it's I plus equals 2, which is basically a syntactic sugar for I equals I plus 2, right? So every iteration, I'm going to take the value of I and I'm going to add 2 to it. So if I hit run, I'm going to get all the even values between 2 and 10, with 2 and 10 included in the range. Let's take another example here. I'm going to paste this code. So if I asked you to write me a program that I would give you a number, and then you would find the summation of all the numbers from 0 to that number. So if I say 4, then you say 1 plus 2 plus 3 plus 4. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So if I give you 4, then 10 should be the answer. If I give you 5, then obviously 15 is the answer, and so on. So how do you write a program that achieves that? Well, in our case here, we have a variable outside of the loop called summation. And I'm starting a loop with the value of I equals 1. And then I'm iterating over until the value of I is 5. And then I'm adding 1 each iteration. And then I'm taking that value and adding it to the sum. So what's going to happen when I print sum equals, let's find out. I get 15. So how did we get 15? 1 plus 2 plus 3 plus 4 plus 5. What if I change that to, I don't know, 500? Let's run that. That's the value you get when you have the summation of all the numbers from 1 to 500 with 1 and 500 included. So how would you change this for loop into a while? All right, so first you want to change the for to while. You want to copy the first part, the area 1, which is the condition initialization, put it outside. And then you want to copy cut the condition update and put it in the body of the loop and get rid of the semicolons. A little bit of reformatting. If you hit run, you get the same result. I'm just going to bring it back to 5. Hit run again, get 15. All right, so it turns out that those two statements, 11 and 12, line 11 and line 12, could be combined into one statement by simply adding plus plus at the end of I in statement number 1 and getting rid of the second statement. So let me show you that they produce, you see, running the code, they produce the same output. So what's actually happening here is this statement is expanded into 2 statements. So you've sum equals sum plus I plus plus. That is how you expand plus equals, right? And then this statement will perform I equals I plus 1, but because the plus plus is after the variable, it will perform it right after the variable is used, right after the value of the variable is used. So basically, you've got those 2 statements encapsulated in this expression, which is basically saying add the value of I as it currently is, which is, let's say 1, to sum, which as it currently is 0, right? And then sum becomes 1, and then add 1, that is the value of I, to 1, which is 2, the next iteration. And then you continue this way. So if this was plus plus, it will turn into something like this, where it will basically come into the first iteration where sum is 0 and I is 1. We'll make I 2 and then add the value of I to sum. So this will actually not give us what we want. This will produce a bug in the code. So let's hit run and find out what the output will be. Well, we got 20. Why is that? See, we started with 2, then 3, then 4, then 5, then 6. So what we're getting is the previous, so previously we had 1, 2, 3, 4, 5, and that produced 15, right? So we don't have the 1 anymore, but we have 6 for the last iteration. So that's 14 plus 6, which is 20. Let's debug it real quick just to confirm. So our first iteration, I is 1, sum is 0. I'm going to hit run, step over to go to the next line, which is going back and evaluating the condition for the loop. And now I get sum to be 2, and then 5, as we expect, and then we add 4, we get 9, and then we add 5, we get 14, and then we add 6, we get 20, and then we break out of the loop and we print sum. So let's consider this program now. So I would like to find the first power of 2 that is greater than 100. So like we all know that 2 to the power 0 is 1, 2 to the power 1 is 2, then 4, then 8, then 16, then 32, then 64, then 128, then 265, etc., etc. So 128 is the first number that is greater than 100. So if you hit run, you get that answer. So how did we write a program that finds that out? Well, what you do is you say while our number is less than or equals 100. Then I would like you to update the value of number. So we start with 2 to the power 0 which is 1 as our first value. And then we say 1, which this is number equals number multiplied by 2, right? So basically what we're saying is every time multiply by 2 and then get out of the loop, compare if our number is still less than 100, continue doing what you're doing until our number is greater than 100, and then print out that number. So pretty straightforward. So with all the loops that we've seen so far, the numbers have been going up with every iteration, whether it's like the value of I or the summation or 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, etc. What if we want to do something different? What if we want to start with a higher number and then decrease our count? So that's exactly what we're doing here. I've got a count that is 10, and I would like to print all the numbers counting from 10 all the way to count greater than 0, which means that we get to print 1, but then once we get to 0, we're not going to print that because 0 is not greater than 0, so we're going to break. Let's try that out. So I get exactly 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What if we would like to change this into a for loop? So for, I'm going to put int count in here with the semicolon, right? And then I'm going to take count minus minus, which is count equals count minus 1. And I'm going to add a semicolon here and put that in there. Get rid of the semicolon at the end and hit run. And I get the same result. So we've seen this print statement before, right? Hello world. I'm going to add another hello world in there, just right after it, and hit run. And I get the two of them printed. Now, why am I doing this? I want to introduce you to this little concept here called an escape character. So an escape character is a character that you can add in your string that starts with a backslash and then a T for tab, for instance. And if you hit run, you get basically the things between the escape character spaced out by a tab. So I can change that to N and then hit run, and I get them spaced out by a new line. So you get the point. So I'm about to show you an example of a new concept that we haven't seen before that is called nested loops. And in that concept, I will utilize those escape characters, maybe the tab for now for the first example. So let me bring it over. All right, so what's going on here? I'm gonna hit run, and I see that what I'm doing right here is I'm printing a multiplication table. How does that work? Okay, so for our first value of I in the outer loop, because the outer loop has an I for its iteration variable, and the inner loop has J for its iteration variable. So we have two variables here that we're basically using to track both loops. So one loop in the outer loop, one iteration in the outer loop will be a full loop, like full execution of the inner loop. So for each iteration in the outer loop, I am doing all the iterations in the inner loop. Does that make sense? So let's see that. I'm gonna put a breakpoint here and a breakpoint here, just to show you what's going on, and a breakpoint here. All right, so running the code in debug mode. I'm standing here right now. I'm in the first iteration of the outer for loop, where the value of I is 1. I'm about to do a full loop in the inner for. So the full loop will start with the first iteration of the inner loop. And so I hit F8, and now I have I equals 1, j equals 1. Now notice that int I equals 1, int j equals 1, I less than or equals 5. So it's basically identical in terms of the outer one will have 5 loops, the inner one, 5 iterations. The inner one will have 5 iterations. However, for every iteration outside, you're having 5 iterations inside. So 5 by 5 is 25 iterations in full. So let's see that. Let's see how that is going to unfold. So I'm about to hit next. So the first line, I should be accurate. The difference between print and print line is if you give something to print, it will print it and stay on the same line. If you give something to print line, which is what we've been doing, it will print what you give it and it will add a new line at the end. So you'll see the difference now. So if I hit F8, I get 1 printed, which is the result of 1 multiplied by 1 here, and then a tab character printed after. So I'll move on to the next iteration where j equals 2, I is still 1, and I get 1 multiplied by 2, which is 2, and then tab printed. And then I move on to the next iteration of j, 3. So 1 by 3, 1 by 4, 1 by 5, and then I'm done with the first complete run of the inner loop, right? And then I get to this line, which will print whatever you give it and then move on to the next line. Well, I'm not giving it anything here in between the parentheses, so it'll just move on to the next line. So if I hit run, we don't see anything being printed here because it's just white space. But if I try to select, I see that the cursor, is here. Now I is still 1. I'm going to update the value of I, executing area number 3, and then going to area number 2 and evaluating the condition and making sure that the next value, which is 2, is still less than or equals 5. So let's do that. I is now 2. And now we're going to do the multiplication table for 2, right? So j is 1 again. So now I'm going to have 2 multiplied by 1 is 2. Then 2 multiplied by 2 is 4, 6, 8, 10. And now that's the final value of j. So once I hit F8, I'm out of the second run of the inner loop. And then I'm going to print a new line. And then I'm going to repeat the process for 3, and then for 4, and then for 5. And now the last value of the outer loop has been successfully executed. Now I'm about to change that value to 6, which will invalidate this condition. So the outer loop will break, and that's it. Now, what if you change that number? Let me just kill this and change those numbers to, I can actually do something like int number equals, let's say 10, or let's just keep it 5 for now. And then I'm going to take that number, put it here and here, and that's going to effectively produce the same result. And then I can change that to 25. And if I hit run, you see I've produced the multiplication table for up to 25. I can change that print line into a print, and in here I can give it new line and it will have the same effect. If I hit run, I see the table being printed. If I get rid of this, obviously, then everything will be on one line. Like you can't see it but it's basically everything is on one line instead of probably if I change this to 3, it'll be more obvious, you see? Thank you for watching the video. Hope it was useful. And as always, give us a thumbs up, subscribe, and I will see you in the next one. Bye-bye.